Good evening, everyone. I welcome you to my YouTube channel. Presenting before you this wonderful tutorial is Hambio Mandamento. We have a question here which is simply saying that we prove that root of 2 is irrational. So I guess many people get confused on how to prove irrational numbers, but with this practice example question, I guess people would be able to expand concepts from this. Okay, so how do you prove that the root of a particular number is irrational? So, you need to consider everything that I'll be writing. In order for us to prove that root of 2 is irrational, please consider everything that I'll be writing when proving. Okay? We use a rule that we call proof by contradiction method. Okay? We use something that we call proof by contradiction method. What does it say? Proof by contradiction method is where we contradict that actually root of 2 is not irrational. Instead, it is rational. Okay? So we say, let root of 2 be rational. You are supposed to write all this when proving irrational numbers. Okay, so we let root of 2 be rational. If this is the case, then root of 2 must equal a over b, where a and b are coprimes or positive integers. Okay, and that b must not equal 0, because if b equals 0, then the function is going to be undefined. The equation is going to be undefined. So at the end of it all, we do not want to get we do not want to get anything that is going to give us common factors. We don't want anything which is going to come out like this, or something which is going to come out like this, or something like this. We don't want that. Okay, so you don't put this, don't put what I've written here, but you can just end where b must not equal 0. But at the end of it all, you know that you don't want this. Okay, you don't want these common factors, because if you have something like that, automatically it's rational. It's rational. If you have something like this, okay, then you have a rational number. Okay, so we don't want that. So now, if we reach here, then we're going to say that root of 2 is going to equal a over b. Then I square this. I'm going to square that. That and that will go. So I'm going to remain with 2 equal to a power 2 over b power 2. Okay? You outline all these steps. So if you cross multiply, you are going to get a power 2 equal to b. So this is going to be 2b power 2. Now when you reach here, you are supposed to divide by 2. You also divide by 2. So you are going to get something like b power 2 is equal to a power 2 over 2. Now notice what is happening here. If I divide 2 into a, I am getting a number which is independent with a power 2. But we know that numbers which are divisible by 2 are called even numbers. So because when I divide 2 into a to the power 2, I'm getting a number called b to the power 2, which is an independent number without a point. It means that a squared is even. If a squared is even, we know that if a squared is even, then even number multiplied by even number is going to give us a squared as an even number. So this simply means that even a is even. So even a is even. Then when you reach there, you must write all this. When you reach there, if a is even, then a can be a number such that 2 is going to multiply k, where k is a number, okay, is where k is any number within real numbers, okay. K is a number where k is a number among real numbers, okay, which must be integers. Then when you reach here, it simply means that you are going to get your b squared equal to, then this is going to be a power 2 over 2. Then this is going to be b power 2 equal to, so what there is a, I can replace with 2k, then I'm going to get power 2 there, then 2. Notice what is going to happen. I'm going to have b power 2 equal to, this is going to be 4k power 2 over 2. Then at the end, this and this guy is going to divide. I'm going to get b power 2 equal to 2k power 2. Okay, so now when I reach here, if I divide by 2, I also divide by 2. Notice that k power 2 is equal to b power 2 over 2. Now, if I put 2 into b, okay, I am getting, I tested for a, because a is an even number and it's a positive integer. Now I want to test for b. If I put 2 into b, I am getting k to the power 2 as an independent number with a power 2, which means that b is even, which means that b squared is even. At the same time, b is also an even number, okay. So you can end the contradiction here. If a is an even number and b is an even number, both of them, even numbers are integers, okay, even numbers are integers, but square root of 2 is not an integer. Henceforth, root of 2 cannot equal a over b. That is how you end the proof. Please, if you found this video helpful, consider subscribing, hitting the like button, and also commenting and also sharing to others. This is just how you need to write all this, okay, to earn all the marks. It's very simple. You can use this concept on all the questions and you'll get everything correct. If you don't seem to be understanding your way, physics, biology, and mathematics, consider registering under personal tuitions under Hampel Kleeman Online Academy. Thank you so much.